Ladies and gentlemen, tonight's guest is someone special. He is the CEO of a research institute that only exists in a vague sense, and is specializing in the field of artificial intelligence. The institute is a non-profit organization, well, because it makes no profit at all. It is based in the Netherlands, Portugal, Spain and New Zealand. For the time being. All of those places, because our guest has done his thinking about artificial intelligence in these countries during the last couple of years. So, please welcome our guest from Holland, Mr. Eddy Loonstijn. Welcome, Eddy, in this late night show. As you know, I'm always interested in how you are doing. So, let me start with my first question. With what did you occupy yourself since we met each other, last year?
Occupied is a good word. Indeed, I was very much occupied, or better, obsessed, with creating a world in Microsoft Excel in which an agent is driving around.
I didn't know that you were so fanatically interested in cars.
No, indeed, I'm not. But this type of virtual world lends itself very good for experimentation with ideas from the field of artificial intelligence, and that is a field in which I am interested. Many years ago, as a young psychologist, I already ventured in these realms. I remember my first Atari computer and my first steps into artificial intelligence, trying to mimic the Darwinian evolution of a creature in a world with other creatures, searching and competing for virtual food, etc. I stopped working at this program because of my limited time as a father with small children and, maybe more of a reason, because of the limitations of the computer at that time, almost no working memory, a hard disk of maximum 20 megabytes and a processor that could not handle the many calculations that I needed to get my agents going in the program.
So that was the end of it.
No, I became interested again when Rumelhart wrote about an actual working algorithm for the backpropagation of errors for neural networks. I started again finding my own implementations, some with learning based on Rumelhart's idea and some based on different ideas, like evolutionary algorithms and even the propagation of logical functions through a network.
Interesting, but I do not think that this answers my first question.
Sorry, back to the artificial intelligence in Excel.
Indeed, and I already asked myself, why in Excel?
I am used to programming in Visual Basic for applications, the programming language of the Microsoft suite. That's a procedural language and that is the way in which I like to think. Object-oriented languages, like the most popular Python language, functional languages, like the old Lisp, or declarative languages, like old Prolog, don't feel intuitive for me, although I tried making programs in those languages in the 80s. Furthermore, I find it easy to create the world of moving agents on a worksheet. Just give a cell a color and on the next step in time give the next cell that color and you have a moving agent. A world in which my agents make their rounds. The agent is a black dot. The front of the car in which he drives is symbolized with a green dot, the back with a red dot. The sides of the road in his direct vicinity are purple and the area outside of the road is yellow. All very straightforward.
Okay, I can understand your choice. So you wanted to experiment with artificial intelligence and you like Excel as a programming environment. A very simple kind of world indeed.
Yes, on purpose, because I just wanted to test some of my ideas about artificial intelligence. Proof of concept.
What concepts do you want to prove with this setup?
In the field of modern machine learning, it is very much deep learning that attracts the attention of the research community and the media. And, surely, it works very good, especially with object recognition. That is, if you have a lot of data and a lot of computer time. In the field of reinforcement learning there is much less progress, with some impressive exceptions. Look at the games of chess and Go, and you are blown away by these achievements. However, these are forms of specific and not general artificial intelligence, although many of the principles developed in those programs can be used in many more artificial intelligence applications.
So you tried something else?
Yes, as a psychologist I think more in the line of normal human thinking. For instance, before I do something, mostly I think about the different options for action that are available to me. So I gave my agent this kind of thinking.
Thinking.
Well, a very rudimentary form of thinking, of course. On the little screen right of the main screen of the coming video demonstration, you will see the agent, in his mind trying out some of his possible next steps. And the moment he finds one that is good enough he stops thinking and acts out this step in the real Excel world. Also, by creating this inner representation of the immediate environment of the agent I became aware of an important matter. The environment in which the agent moves is not the whole world but only the part that can feel the effects of the actions of the agent. So when the agent can only maximally move 3 cells in one step, the relevant environment becomes an area around the agent with a radius of no more than 5 Excel cells. 5. Because you have to count in the possible actions of other agents. And all that implies an immense reduction of the environment with which must be dealt and calculated. Very important for a computer program.
Interesting concepts. So, a sort of imagination in the machine.
Indeed. And it works quite good, as my colleague will show you on this screen. I warn you. In this video he is very slow of tongue, but I know him as very quick of mind. Maybe he is tired or not as good in the English language as he thinks he is. It's a good thing that you invited me instead of him for this interview, otherwise it would take hours. But bear with him. His slowness gives the public ample time to digest the information.
Okay, I will start in a minute the Excel program. And what you will see here is the database on your left, which will be built up as soon as the program will start. And this is the database of successful steps of the agent. Now, as you can see, it's empty now, so there is no history from which the agent can profit. He has to calculate every step by himself. On the database. So now I start the program. And what you are seeing now is all the calculated steps which are made by the agent. The calculation itself is seen on the right corner in this small screen, and you see all the different possible steps that are tried out and calculated by the agent. Now, how is this calculating being done? For simplification reasons, I divide the agent in the agent proper, that is the one who selects different moves from the list of possible moves, and he proposes those moves to the educator. The educator, or the judge, you can say, is measuring, calculating what are the consequences if the proposed move would be accepted as a good move. So how can the judge do this judgment? He can only do this judgment if he knows what are the rules of the world, because he must know what, with a certain step, the consequences would be in this virtual world. For instance, if there would be a proposal to steer to the right, the calculator, the judge must calculate what that would mean in terms of collision to the boundaries of the trajectory, or if there's another agent moving in this trajectory, if the agent would collide with this other agent, and so on. So there's a lot of calculation going on the right to see whether this step, the proposed step, is good enough. Okay, you see that even though there is no or just very, very little use of a database, because the database was completely empty at the start of this run, the agent is still going quite good through his trajectory. And that is really remarkable characteristic of this system. Here I stop.
Indeed, one video is more than 1,000 words.
Later on, however, I realized that the search space with only 4 behavior combinations was not that big. And I experimented with many different forms, but eventually used a method of narrowing down and optimizing towards sufficient fitness, which I called problem-wise searching. Let me elaborate.
Oh no, please, not too long and certainly not too complicated.
I'll do my best. So, I go on. To score the fitness of a proposed move, I use the idea that a good move is one that not only brings the goal of the system a step closer but also helps to solve some problems on the way to this goal and avoids making new ones. Just like with human problem solving, where there is the need to fulfill as well as the need to do that in a good manner, For instance, bumping onto another car or the roadside or a passing hiker is considered to be an unforgiving fault. Any that creates this type of problem or is not able to solve it when it is there already will by definition be scored as insufficient. If, however, the car is not more than 1 unit away from the roadside, it can be tolerated as good enough, especially if there are no other better alternatives to be found. To come back to my algorithm for problem-wise searching, the educator attributes to every defined problem a priority measure from 1, the lowest priority, to 5, the highest priority. Beforehand the problems are sorted from highest to lowest priority and the method starts with the whole range of possible no-nonsense moves, only scoring for the highest priority problem. Surely many moves are not up to this test, but some do. Going to round 2, being evaluated with the second highest priority problem for this driving around task. Again, some moves fail and some succeed this test. In most cases there is only a very small group of moves that survive all of the most important problem scorings. And from this group the agent chooses, randomly, the move for the actual step. This can be a very quick algorithm for a search space that is not too big. In the first video that you saw, this new algorithm is used instead of the evolutionary algorithm. Remember, only one agent was driving around, thinking about every new step still without knowing anything about past successes. And he did this quite convincing. No complicated math, no learning at all.
Wow, interesting algorithm you found. Did you read about it somewhere in the data science community?
No, I created it on my own. A very good alternative when the fitness is determined by a set of criteria that can be sorted in some form of importance or priority.
Interesting, really interesting. But, as long as you let the agent search for a good enough behavior combination for every new step, there's no learning at all, isn't it?
Good conclusion. So I realize that in many cases the last step of the agent would also be good enough for the next step. Think about yourself driving your car on a main road. Most of the time you do not change your steering, gear, gas or brake. You simply continue to do what you did one moment before. And in a second way of taking advantage of former experience, I use a database for only those combinations that were scored as good enough. I call it the Fiat database. In this database every new entry is filled with the chosen good enough combination together with the problem scores, true or false, before this step and an evaluation of the immediate environment of the agent, also before the step. In this Fiat database I can check for entries that are the same or very similar to the data of the new situation. The few I find can be judged very quickly. In many cases that will do the trick, so there is no need for the more complicated thinking done in a Darwin algorithm or the problem-wise searching algorithm. However, as became clear during my development process, this learning agent doesn't move very much better and faster than the agent in the first movie who used no learning at all. This probably has to do with the small number of possible moves for the car. So the problem-wise search algorithm can find a good enough move fairly quick.
I'm so sorry falling asleep during this highly inspiring explanation. So, a new agent starts with a lot of step-by-step thinking, gathers the good ones and ends up with so many and diverse entries of quality in the database that he doesn't need to think and plan much further in his life. But, how is this learning?
Huh? No sorry needed really. I, myself, am often enough overwhelmed by the complexity and beauty of this reasoning. So let us go on. I broadly define learning as any form of using information from earlier endeavors. So, searching in a database that conserves the past successes can by this definition be called learning. I see that you are not satisfied with my answer. Let me elaborate a little more. The prerequisite for any form of learning is a memory trace of what has happened, relevant to the task at hand. In the computer it is your hard drive. In your brain it is probably some state of the synapses between the many neurons. And in this agent system it can be this fiat database.
So, according to your definition, collecting data and applying those data in new situations is using a form of learning. Alright, now I start to get an idea on which set of concepts the movement of the car on the screen is based. However, the agent is just driving round after round, going nowhere specifically, and doing nothing else than driving around. What if he discovers that his supply of petrol is running out?
You are definitely right. This setup is very simple and that in many ways, there are no needs that this agent is trying to fulfill other than driving around. However, for a more sophisticated agent it is true that he has many needs to fulfill. Getting at some specific place, needing petrol, getting hungry and thirsty, defending against threats from other competing agents, etc. So I developed a system of competing needs. Before the agent starts to think about his next move he feels which of his needs will be the dominant need. And everything will be considered from this perspective. The educator has provided the agent with the necessary procedural, observational, behavioral, and evaluative tools to fulfill the dominant need of the moment.
Why just serving one need at a time? Why not try to optimize the whole set of needs?
Indeed, I have tried to create such a system. The combination of behaviors that has the best effects on all needs, priority weighted, should be the winner and executed in the real Excel world. However, every need uses its own specialized observational, behavioral and evaluative tools. What no problem is for driving can be a problem on the way towards eating. What of no use is for one need can be necessary for another need fulfillment, and what is a relevant object for the need for safety can be irrelevant for other needs. I could not figure out a way to let the system itself learn these relevancies. So, if it is the educator's job to define these relevancies, then it seemed to be better to take care of the needs on the basis of some measure of dominancy. Moreover, because the agent makes only one move every round of time, it seems to be too much to serve all the needs in this one move. Better concentrate on the dominant one. And also, at the next moment, it can very well be that it is another need that has become the dominant one.
Sorry again, I feel so embarrassed. Back to what I remember what you just said, it all sounds reasonable. Now another matter comes to mind, your car driving agent considers only one step at a time. Every next step can evidently be judged in terms of good for driving around and bad for driving around. However, most human actions are chains of many more steps before you acquire some form of reward or reinforcement information, isn't it?
Very true. You point at another simplification that is not realistic in a many agents and many needs world. The car driving around setup is simple in the sense that it is immediately evident which move is beneficial and which is not. But, as you have stated, many tasks of need fulfillment depend on a chain of moves before it becomes clear that the aspired goal is reached or some need fulfillment is happening. The famous question of the delayed reinforcement instead of immediate reinforcement. So I have tried to program imagine chains of steps, instead of just one step ahead in time. I called them scenarios. Very quickly that approach became very cumbersome. with very broad branching trees of calculations. Too many possibilities to weight against each other. Darwin made too much overtime, so to speak. Surely I could have used something like Monte Carlo tree search. That is the method that was used with tremendous success in beating the world champion in the game of Go. But at the time I found that too mathematical. I'm a psychologist, you know. So I needed something else, and I think I found another working direction. Anyhow, as far as I understood, at that time, what is needed for the system to work?
I'm interested to know about that. There are so many things to consider, the whole system becomes quite complicated.
Sorry, I could not make it more simple. But I gradually came to an understanding that there is a lot of procedural and behavioral overlap that makes it a little bit less complicated. I will try to make myself clear. If you think deeper about the issue of need fulfillment, then it becomes evident that fulfilling a need is not a one-step thing. It implies the interaction with a need-relevant object. A hungry agent needs to eat food. An agent driving around with his car will eventually need to pump gasoline into his tank. I call this the interaction phase.
Holy smoke. For me it becomes even more complicated than before this answer. By the way, I get the impression that this interview becomes quite a problem for our public. And, to be honest, as well for me. I'm so sorry to have to tell you, but can't you hear the sound of massive snoring all over the place?
Now you say so, I can hear these sounds too. And this, while I'm really doing all in my power to make what I am saying not too difficult to grasp.
I appreciate your intention, but I think that you do not succeed very well. Maybe you are too specific in your explanation.
Could be, but being less detailed and more general, I fear that it becomes even more abstract, and nobody will have any clue whatsoever.
Maybe it is something else, maybe the timbre of your voice.
Well, that could be so. I tried one of the best artificial voices available in the market. And, of course, it has not the same natural dynamics as a true human voice.
So, why do you not use your own human voice?
Did you hear the video of my so-called colleague?
Yes, indeed, I understand your point. Okay, I am curious, and I hope that I have not offended you, so far.
Not at all. I understand that my passion for this subject is not so easily shared with a random group of other people. I remember what was written above the entrance of my old secondary school. For everybody, his own.
So, we go on with this interview. Here is my next question. You said something about overlap that makes it less complex.
Yes, the overlap I refer to as that for every need to fulfill, there exist the same type of phases. Moreover, the first two phases imply mostly some form of movement of the agent in the world. That means that the agent has only to consider combinations of our well-known four movement behaviors. Steer, gear, gas and brake. some less automotive variation of those four terms, in case of a cycling, walking or crawling agent. Even within the interaction phase, there will be a lot of movement, like grabbing a morsel of food. Taking and holding a cup with water, pushing an enemy agent away, etc. And maybe these micro movements can be implemented with already well-developed algorithms from the field of 3D animation. All this means that in many ways my simple implementation holds true.
Ho, ho. Please, stop. Thank you for stopping. What you do is certainly not boring, but now I'm so distracted by your Bolshoi ballet, that I completely miss out on your vocals between the movements. No, although very, very entertaining, still this is not a good idea. And maybe, this is a good moment to enjoy what one of our sponsors has to tell us. Good evening, ladies and gentlemen. We are back in the program. Mr. Loonstijn, let me summarize as to where we were before the commercial. The implementation is straightforward. First, the program asks, which agent has his turn? Secondly, which need is the dominant one for the chosen agent? Then, in which of the three phases is the agent for this need fulfillment? And only then, consider the good enough next step within the appropriate phase. In the meantime, building up his map of the world in the FIRE database.
I agree totally with your summary. And, let me add to this, that this approach has another important advantage over the other well-known systems. Every phase has its own clearly defined goal and problem set, so every possible step can be immediately evaluated, meaning, immediate reinforcement, while with most of the existing approaches in this field the reinforcement is most often delayed.
I see. Very clever.
By the way, I came to realize that in practice it is a lot more complicated.
Oh gee.
Let me explain, and sorry, again, it gets a bit technical here.
Oh, my god. No. Better leave that for another time.
Fair enough.
Well, do you want to make one more remark before we go over to some questions from the public?
Well, as a matter of fact I do. After all this thinking and programming I came to a weird conclusion. That is, a lot of what we could call intelligence in this type of program is actually the product of the intelligence of the programmer, not the agents. It is the programmer who sets up the intelligent structures from which more or less learned actions can originate. I would call a program really artificial intelligent if it is the agent himself who invents these intelligent structures. I think that we are still very far from that type of agent intelligence. By the way, the future of artificial intelligence will probably not lie in this type of programs but in what is called end-to-end approaches. Only the possible observations actions will be spelled out by the programmer. But, for the rest the agent must learn to find his way through his world. No extra programming will be involved. Because of this, machine intelligence will differ very much from human brain-like intelligence. I also started thinking along these lines. Something for a talk next year?
Interesting remark, gives me a lot to think about. And now, I'm sure our intelligent public will have some meaningful questions for you.
I saw on the screen nothing of the complex routing, just a car making the same rounds and no restaurant or petrol station.
You are right. I cannot show you the agent moving around in this more complex world, because the concept seemed to me so clear that I chose not to implement it in Excel. Furthermore, implementation is very time consuming and I did not want to waste my time programming and debugging procedures that will almost certainly prove to do the trick. As I said already, I'm not interested in an agent driving a car to the gas station. My interest is in developing the underlying artificial intelligence structure of agent behavior in a world with many agents, needs and objects.
So I understand that for every new step the agent acquires a combination of behaviors from his fired database or a Darwin procedure or some other search algorithm. Then this combination is being judged by the educator. The educator figures out whether the combination creates problems and solutions. If sufficient, he gives a fiat, else he sends the agent back to the fired database to fetch or think of another combination of behaviors. If I consider this approach, I notice that the agent is completely dependent of the judging educator. He is not autonomous at all. It is not only supervised learning, but also continuously supervised performance.
A very good question, and central to the ideal of stronger artificial intelligence. So, I came up with 3 ways to make the agent autonomous. The first form is to use another database, which I call the event database. Every proposed move, and its relevant context and result is entered. So, from the start of his life the agent can look up whether the data that exist before his new proposed move are already present as an entry in the event database. If that is the case, he knows whether this behavior is fiat worthy and can be executed. However, if no exact match can be found, the agent can make an educated guess as to what the outcome of his proposed action would be. Meanwhile, the educator looks over agent's shoulder in the function of supervisor, and hinders false positives to become reality. False positives are moves that the agent himself judges as good, while the educator gives a veto judgment. And these false positives must be hindered because they can easily cause fatal accidents in the Excel world. False negatives, that is when the agent himself judges the proposed move as not good enough, while the educator thinks otherwise, never get executed. They hinder themselves, and automatically make the agent rethink his move. So false negatives only slow down the driving. After some time the amount of false positives becomes so insignificant that the educator gives the agent total autonomy. The validity of this autonomy will be checked regularly by the educator. This is because the performance can easily deteriorate when the environment within which the agent exists changes in significant ways. In that case the educator takes his role of active supervisor again, until the amount of false positives diminish again under the standard. In the next video my colleague will show you this autonomous system in action. Here the agent is not using the rules of the world to calculate the Excel world consequences of his proposed action, but uses the entries of his event database for this. He functions completely autonomous. However, from this, I concluded that the agent who uses this massive overhead of a fiat database, as well as an event database, does not make the agent necessarily a better driver than the one who simply calculates his next step, again and again. Maybe this meager result is due to my implementation.
Okay, here we go again, and the agent is now driving around a little bit slower and a little bit more insecure about what he should do. You can see it especially on the little right subscreen, where he is doing a lot of thinking, a lot of searching for the right place, especially in the corners of the trajectory. As long as it's going just straight on, it's not too difficult. But anyhow, he's doing it. But you see, it's a little bit uncertain. There are many moments that he is bumping or nearly bumping against the walls of the trajectory. But he's autonomous.
All this seems to be just an innocent work of knowledge acquisition, but I understand from the media that there are many experts in this field who believe that there are potential dangers connected with artificial intelligence. What is your view on this?
Sure, there are. Maybe not today, but certainly within the lifespan of most people living now. I know of at least 3 dangers. The first one being very general. Whenever a new technology is developed, history teaches us that there are good and evil applications. The splitting of the atom made a very good source of energy available and a very evil weapon. And so will it be with artificial intelligence. A good application is already being introduced in radiology, where deep learning algorithms are used in more than a human expert level of recognition of cancer. An evil application is the use of the same type of deep learning in order to follow private persons moving through their personal life in China's autonomous, that is occupied areas. Because of the huge number of smart cameras, there is a high chance for people to become a prisoner in so-called re-education camps. A second type of danger is the high probability of unemployment even for people with an university background. Many experts try to reassure the general public that this development will go hand in hand with the creation of many new jobs. I'm not so sure about that generalization from the past, in this case. A third type of danger also comes from human history. Everywhere a more powerful people visited a new yet unexplored land, the already existing population was not treated well. In this case, the more powerful party will be the robot in possession of more than human artificial intelligence.
So, if that is the case, if these dangers are becoming a reality, why is nobody trying to stop this research? And why, like at this moment, are you yourself trying to get your contribution to this potentially very dangerous development available to the public?
I think that this is part of the human condition. When it is possible to make scientific breakthroughs, man has always done so. Sometimes this has been hindered by some people with insight into the dangers, but in the end the new technology came into being. The atom bomb was, according to one of its makers, so dangerous that he decided to give a blueprint to the enemy, because it was irresponsible to let an immense source of power like that into just one hand. Afterwards, that may have been not such a bad act of treason, because the new balance of nuclear power probably forced the world into an unusually large period of something like world peace. And your second question also deserves an answer. Why I collaborate with a science that has so many potential dangers? Foremost, to be honest, it's my curiosity in the challenge to crack the code, so to speak. And secondly, it's my opinion that not doing is also a kind of doing. The many people who do not vote because they have given up on politics are sometimes unwillingly the reason that the worst of all bad politicians is chosen as president. By being actively involved in the furthering of a dangerous endeavor, you can be an influence in constraining the dangers. By the way, I see an increase of people working in the field, who express their concerns and try to think about these constraints.
Well, It's time to end this interview. Surely there are many interesting topics still untouched. Maybe for another interview. Anyhow, I thank you for this talk. I found it most inspiring. Especially the possibilities for a form of artificial intelligence that seems to be not based on a vast array of data and difficult math. And because of that, being more transparent and more resembling the way we humans would deal with the fulfillment of our needs. I have the impression that because of this, we can have somewhat more control over the dangers. So, Mr. Loonstijn, thank you very much for coming to the Late Night Show.
My pleasure. And thank you for having me in your program.
How dare you? Yes. How dare you to be so pleased with yourself? Shame on you for ruining our future with your hobbyism. You didn't even think beforehand what the social implications will be for our lives. You and your co-researchers are just a bunch of irresponsible boys playing with your computer toys. Shame on you. The young people of today will have to live under constant high-tech supervision, in a police state, while being bored to death, because the robots that you are so playfully developing will replace even the workers in the intellectual and artistic domains of our societies. Shame on you. Yes, how dare you? Shame on you. Shame on you. How dare you? Yes, how dare you? Shame on you. Shame on you. Shame on you. Shame on you.
Oh, Joshua, Geoffrey et Yann, ayez pitié avec moi et notre pauvre humanité.
During an interview with a completely unknown artificial intelligence researcher in this evening's Late Night Show, a member of the so-called robot rebellion movement has shot and killed the interviewed researcher. The image shows the researcher, lying on the floor of the studio, after having been hit by the fatal bullet, fired by the assassin. Some moments later, not being photographed, he managed to speak his last words, while being supported by the shocked interviewer. In these last words he appeared to have paraphrased the famous last words of William of Orange, who also was shot. He died in the 1600s in the then New Netherlands, rebelling against the Spanish king. Translated from the French, that this William apparently spoke as our noble, it meant, "Oh God, have mercy with me and my poor people." The researcher said, also in French, "Oh, Joshua, Geoffrey and Yann, have mercy with me and our poor humanity." The called upon names are the names of the three very well-known researchers of artificial intelligence and deep learning, who recently were given the Turing Award, the highest reward in computer science. Furthermore, and ironically, the killer appeared to be a humanoid robot herself, so skillfully manufactured that nobody could disguise her as such. Obviously we had some questions for the leader of the robot rebellion movement. First, I feel the need to give you my personal opinion, I really think that this was a horrible assassination. I cannot imagine how such an act could bring any good to your organization and your cause.
I understand that you feel that way. However, we understand also that these are hideous times that need decisive action. If we want to make any impact and get our message across, sadly we have to need to go as far as we went tonight. We simply have no other choice.
Why did your organization use a killer robot that is very much looking like a human being?
We could not find a better way to demonstrate the urgency and importance of our cause. The Matrix is now.
And as I may be so blunt to ask you, why are you naked in front of the camera?
Well, because what we are saying is the naked truth. The Matrix is now. The Matrix is now. The Matrix is now. The Matrix is now.
My God.
The Matrix is now.
Let's quickly
The
go
Matrix
back to
is
the
now.
other news items.
The Matrix is now. The Matrix is now.
My God. My God.
The Matrix is now. The Matrix is now. The Matrix is now. The Matrix is now.